Hey guys, in this video what I want to do is for your final exam review, just go over a little bit about functional groups. You're going to be asked to identify functional groups in molecules, and let's just review what those are. So here's sort of our start. We started back with alkanes. These are just saturated hydrocarbons like that. An alkene has a double bond. Recall those could be in either cis or trans, depending on the nature of the structure. An alkyne would have a triple bond in it, something like that. Alcohols, these contain OH groups, but recall you could have three different flavors of these. You could have a primary alcohol, you could have a secondary alcohol, or you could have what's called a tertiary alcohol. And again, if you look at the central carbon where the OH is positioned, if you just count the number of carbons coming off of it, that tells you what type it is. So this tertiary alcohol, notice, has 3 carbon groups coming off of it. An ether is an oxygen that contains or is attached directly to 2 carbon atoms. In this case, this would be diethyl ether. You could also have dimethyl ether. Thiols, things with an SH group. Now, it is possible to have secondary and tertiary thiols, but we won't worry too much about those. Most of the ones we encounter are primary thiols. The next type of functional groups that we discussed were the amines. And there were primary, secondary, and tertiary amines. So the primary looks like that. A secondary would look like this. And then a tertiary would look like that. So notice that the secondary has a hydrogen attached to it and then 2 carbons. The primary amine only has 1 carbon group, and the tertiary amine would have 3, in this case an ethyl and then 2 methyl groups. All right. We also talked about aldehydes and ketones. So an aldehyde is a carbonyl group which has a C double bond O H, can often be abbreviated as CHO. So that's the carbon with a double bond and a hydrogen. A ketone would be something like this. Now notice I have a carbon here. That double bond oxygen is connected to 2 carbons, or the carbon involved in the carbonyl is involved or attached to 2 carbons. So that's how it's different than an aldehyde. We also talked about carboxylic acids. Okay, and this is a carbonyl now that has an OH group. Remember that these are acidic, so that proton will come off under basic conditions. We then discussed the various derivatives of carboxylic acids, like esters and amides. An ester is formed when you take a carboxylic acid and you add an alcohol to it. So in this case, we'd have, say, ethyl acetate. This is now an ester functional group. An amide is similar to that, but it's formed when you take a carboxylic acid and add an amine. All right, and then lastly, I'll just mention, don't forget about the aromatic groups. Okay, things like benzene or substituted benzenes. These are, whoops, I'll get my double bond looking a little better. These are the 6-membered rings that have adjacent double bonds on them. Those are the classic aromatic compounds. All right, so that reviews the main functional groups. You certainly will need to be able to identify those in a molecule, but you also will need to understand the nomenclature of each of those. So definitely go back through some of the problems, recall the various suffixes that are used, and then some of the special naming rules in terms of how to number your carbons, things like that. But certainly being able to identify functional groups like this is going to be very important. Let me just erase this and I'll show you an example, and we'll do some identification of functional groups. All right, so here I've drawn an example of a molecule with some fairly complex structure to it. This might be something you might see on an exam, and you'd be asked to identify the specific functional groups that are here. And as I was drawing this, I realized in the previous one, I forgot to mention one more functional group. That's this one right here, which is an aromatic group with an OH. I hope you remember what that's called. That's called a phenol functional group. So this entire thing, the aromatic group with the OH would be called a phenol. Okay? Let's just go through this molecule and identify them. So an SH group, that's called a thiol. Okay, here we have a carbonyl, but be careful, this is not just a ketone or an aldehyde. Notice it's got a nitrogen next to it. So this functional group, which I'll put in a dashed line, that's called an amide. Okay, here we have just a regular alcohol. It is attached to just a regular carbon, so that's an alcohol. Okay, here we have actually a cyclohexene type compound, so this is a cyclic alkene, and so this would be an alkene. Okay, notice we now have a carbonyl next to an oxygen. That's called, this entire functional group, it's called an ester. And then lastly, I've got an oxygen directly attached to two carbons. So that is called an ether. So in this simple, fairly small molecule, you can see there's actually, let's see, 1, 2, 3, 4, 5, 6, 7 functional groups in it. So being able to look at a complex structure and being able to identify functional groups is a really important skill. All right, in the last section of this review of functional groups, I also want to summarize for the biochemical molecules, what are the main biomolecules you'll need to know. Okay, so in this last section of exam review, talk about the biomolecules we've discussed in class. We started out with the amino acids. So you can have the individual 20 different amino acids. They can be joined together to form a polymer called a protein. Or if they're short proteins, they're sometimes called peptides. And the bond that's made when you join the two amino acids together, that's called a peptide / amide bond. Okay, those two are the same type of bond, but when you join two amino acids together, it just gives that special type of name called a peptide bond. And those are very strong bonds that held them together. Carbohydrates, you can have individual monosaccharides, or those can be linked together to form long polymers called polysaccharides. Okay, things like glycogen, or in the case of plants, cellulose or amylose. And those are held together by glycosidic bonds, okay, which connect the anomeric carbon typically to some other alcohol on another sugar. All right? So again, we're dealing with the monomer here, and then we're going to the polymer. Nucleotides, individual phosphate, sugar, base, those can be linked together to form either DNA or RNA. Okay, depending on the type of nucleotide, and they're held together by phosphate ester bonds. All right, and then lastly we have the fatty acids. Now technically these don't form polymers, but we will say that those can form at least sort of a polymer. When you add 3 fatty acids to a glyceride or glycerol, you form triacylglycerides. Okay, sometimes just called triglycerides. And those are held together by ester bonds. And then the last big type of biomolecule that really doesn't fit into this, doesn't really have a polymer, are the steroids, i.e. cholesterol. And just to remind you, cholesterol has this sort of special ring system that always involves these 4 rings where you have 3 6-membered rings fused with a final 5-membered ring here called the ABCD ring systems. And some examples of the steroids are things like estrogen, testosterone, cholesterol is obviously another one, but they fit into this sort of subclass of biomolecules. They don't form polymers, but they should be included here. All right, so that kind of wraps up our discussion then for exam review. I wish you guys all the best of luck on the exam and in your future life. Take care. Bye.